In this video we have two problems to solve, one polynomial inequality and a rational inequality. You can pause the video and see if you can solve these, and then I'll be back. Okay, the procedure I'm going to use will be very similar to the one that I have shown in other videos, and I use it when I'm going to graph a polynomial. I use this procedure when I'm going to graph a polynomial function or graph a rational function. So I have my number line here. So just like if this were, let's say this was y or f of x and I wanted to graph it, I do the same thing. I would go ahead, one side would have to be 0 here, then I would factor it. So take out an x here, that will leave me with x squared minus 2x minus 3. And then I would factor out the trinomial, and this would be x minus 3 and x plus 1. And this is greater than 0 here, greater than 0 here. And then I would just take the zeros of this polynomial. Factor x would give me a 0 of 0. X minus 3 gives me a 0 of 3. And x plus 1 gives me a 0 of negative 1. And I would have infinity on this side of the number line and negative infinity over here. And then I would just look at the sign of this polynomial in the intervals from 3 to infinity, from 0 to 3, negative 1 to 0, negative infinity to negative 1. So all I do is pick a number a bit larger than 3. I could pick 3.1, 3.5, but anything will work as long as it's in that interval from 3 to infinity. So I'll pick a 4. Put a 4 where the x is. 4 and 1 is a positive. 4 minus 3 is a positive. And of course, 4 for x is a positive. So they're all positive. So the product of 3 positives is a positive. So I simply put a plus sign. Then between 0 and 3, I'm going to pick any number you want. I'll pick 1. Put a 1 where the x is. 1 and 1 is positive. 1 negative. 1 minus 3 is a negative. I don't really care what the number is. I just want to know is it positive or negative. And I put a 1 where the x is. That's positive. So I get 1 negative out of this. So this is going to come out negative. Between negative 1 and 0, I'm going to pick a negative 1/2. So negative 1/2. And for x is a negative. Negative 1/2 minus 3 is a negative, and the negative 1/2 and 1 is a positive. So product of two negatives is positive, and then we got a positive. So in here it's a positive. And then to the left of negative 1, I'm going to pick a negative 2. Negative 2 where the x is, negative. Negative 2 minus 3 is a negative. Negative 2 and 1 is a negative. The product of three negatives is negative. So there you have it. So if I was graphing this polynomial, I would say that the graph is above the x-axis, to the right of 3, below between 0 and 3, above between negative 1 and 0, and below the x-axis to the left of negative 1. But here I'm not interested in the sign because I'm solving the inequality. So actually I want the interval where this polynomial here is positive. So where is it? Right there. From 3 to infinity, and from negative 1 to 0. So my solution then for this one is going to be, put it over here, 1 greater than 0, so that's going to be negative 1 to 0. So from negative 1 to 0, I want positive, so that's right there. And then it's a union here, together with, we're looking at the intervals that generate a positive value, and then if we pick numbers larger than 3, so this would be 3 to infinity. Let me make that infinity a little bit better here. Now this is your interval notation, and this is what I would ask my students to give me, but there's some instructors who might ask you to give the set builder notation. So this would be the equivalent of that using sets here. It's a set of all x such that x is greater than negative 1, so this would be x greater than negative 1, but it has to be less than 0, or x greater than 3. So again, the first one here, this one is what I ask the students to give the answer in interval notation, and this is the set builder notation. They're both correct, just a matter of what the instructions say. Now the next one is a rational inequality. The first one was a polynomial inequality. This is rational. Now I want to point out to you that the technique here is, if it's a polynomial, you want to factor it out. You want one side to be 0. So let's say they give it to you with the plus 3x on this side. Then you add a negative 3x to both sides to get it in this form. You want one side 0, and then you factor and then you apply this technique. Similarly with rational expressions, in this case rational inequalities, it might be that here you have two rational expressions added up, or you might have one over here on the right side. You bring it over and you want to combine them. So you want one side to be 0, and then the other side you want a single rational expression, and you want it factored out. So this one's already factored out, but this could have been given to you as x squared minus 1. So you would factor. You want the numerator and the denominator factored out completely. We find all the numbers that make the numerator 0. So this one's factored out, so you can see that the numbers that make the numerator 0 are 1 and -1. The numbers that make the denominator 0 are 0. Then you plot these. Okay, so I put the 1 and the -1. And then on this side, to the right, that'll be infinity plus infinity. And the other side, that's going to be minus infinity. Rules for multiplication and division are pretty much the same. A negative times a negative is a positive. Negative over a negative is a positive. Negative times a positive is a negative. Negative divided by a positive is a negative, and so forth. So now we just look at the sign. This side has to be 0. Pick a number larger than 1. So let's say 2. So 2 minus 1 is positive. 2 and 1 is positive. And 2 down here is positive. So 3 positives. 2 in the numerator, 1 in the denominator, so the whole thing is positive. And you can see that most of the time, depending on whether you have a repeated factor, the signs here are going to alternate, positive, minus, plus, and so forth, or minus, plus, minus. But sometimes it won't do that, depending on the factors. If you have one, let's say you have a square here or a square over here. So if you're not sure, check each interval. Now, between -1 and 1, well, I forgot my 0 here. So I need to put 0 here also. So 0 here. So now when I check the interval between 0 and 1, I already got the sign from 1 to infinity. So from 0 to 1, I'm going to pick 1/2. I could pick anything between 0 and 1, 1/3, 1/5. I'll pick 1/2, and then I go 1/2 minus 1 here is a negative. 1/2 and 1 is a positive. And a 1/2 down in the numerator is a positive. So 2 positives here and a negative and positive in the numerator. So this is going to be negative. Between 0 and 1, this expression is negative. And then we go to the next one. Between -1 and 0, I'm going to pick -1/2. So -1/2 and minus 1 is a negative. -1/2 and 1, that's a positive for that factor. And a -1/2 in the bottom, that'll be a negative. So I got a negative times a positive is a negative, divided by a negative is a positive. So there we have it. And if we follow the pattern, the next one should be negative, but sometimes it won't do that, depending on, like I said, depending on you have repeated factors or not. So let's check it out. Let's pick a number less than -1. Here we have an option because it goes from -1 to negative infinity. So you got a bunch of numbers, but I'm going to pick a -2. So -2 here, -2 and -1 is a negative. -2 and 1 is a negative. -2 here where the x is a negative. A negative times a negative is a positive, divided by a negative is a negative. So there we have it. So now we want the interval where, what do we want? We want this expression right here has to be less than 0 or negative. So you look at the intervals that have a negative. That's where the solution is going to come from. Okay, so there's a negative right there. There's a negative right there. That's what we need. So in interval notation then, it's going to be -infinity to -1. And notice this one has a less than or equal. So we want the values that make it negative or less than 0, or equal to 0, I should say. So in this case, we want brackets on this one. Okay, -infinity to -1, and because we want it also to be less than 0 or equal to 0, we want the numerator can be 0 at -1, and then this will be union. The other negatives between 0 and 1, and this again numerator is also 0 at 1. So that means open at 0. It cannot equal to 0 because remember here, if you put brackets means the number is included. So bracket means you're allowing 0 in the denominator because x is equal to x would equal to 0. So we put an open parenthesis there, no bracket, and this will be a 1. And it can't equal to 1, so we put brackets right there. So now if it didn't have this equal right here, if this was just less than. This would be pretty much the same. The only difference is instead of brackets on this -1, it would be a parentheses. Instead of a bracket on this one over here, it would be a parentheses. That's the only difference. And then for your set builder notation here, that's interval notation. And if the instructor asks for set builder notation, then you want, in this case, x can be, for this one here, this one translates to x less than or equal to -1, okay, because of the less than or equal here. And then or x will be greater than 0, okay, no equals on that one. X cannot be 0 because it's in the denominator for that particular one. Don't want a 0 in the denominator. And then this would be less than or equal to 1. And we have parentheses. So this is what I usually ask my students to give the answer as. Interval notation. Thanks for watching. We'll see you next time.